This is for those who believe in the potential of science, making brave choices, choosing to push the boundaries. This is why we believe in what science can do.
Good afternoon, everyone. Just trying to see where to speak to you from. I'm not going to stay up here all the time, by the way. I'm going to come down and actually interact with you at some point. But I wanted to start by telling you that this is really about the joy of learning. You know, each of us has a certain area of knowledge that we have right now, and then often with someone's help, a parent, a friend, a teacher, you cross that boundary into what you didn't know before and you learn something new. And that can be really exciting. And learning new things is like playing to me. It's very enjoyable, and my playground is the universe. So I want to share some of the universe with you. And it's kind of difficult, though, because you know, there are some huge sizes of things involved, some vast distances involved, and can we really appreciate that? Can we understand those big numbers? And to help answer that question, let's try a little experiment. We can all do this now. Okay, what I want you to do is close your eyes and imagine one apple. Everybody have their eyes closed? You see that apple there? Okay, so there's this one apple. Now imagine two apples. See two apples? Good. Now imagine three apples. Everybody's okay with three apples? Excellent. Now imagine 47 apples. Not 46, not 48, but exactly 47. Okay, you can open your eyes. How many of you were able to see exactly 47 apples? Okay, we have a few aliens in the audience because I don't think humans can do that, actually. But the point is that if we can't really picture 47, how are we going to understand numbers like, 93 million miles to the sun? And one way to try to understand these things is to use analogies, use models, and build bridges from things that are familiar. Okay, so for instance, well, let me just do that. Let's say we want to know how big the U.S. is. How big is how far is it from the East Coast to the West Coast, approximately? 3,000 miles, maybe? If you were to drive, has anyone driven across the whole U.S.? Has anyone driven across without stopping, except for maybe bathroom breaks and food and gasoline? Has anyone driven nonstop? How long did it take? Okay, you didn't worry about speed limits, I guess. But if you drive at the speed limit, I think it would be about 2.5 days, something like that. So that gives you, and you can imagine sitting in a car for 2.5 days, what that's like going across the U.S. But if you can imagine that gives you an idea of how big the U.S. is. Now, how big is that compared to the Earth? Okay, so talk about the whole Earth. How many United States would we have to put across to equal the diameter of the Earth? How many say more than 5? How many say 5 or fewer? Okay, well, the answer is actually about 3. I don't know if you can see it there. Here's my portable inflatable globe. And I like this globe because it really shows the Earth sort of like it really looks from space, without all those longitude and latitude lines and labels and boundaries. Here's the U.S., and it takes about 1, 2, 3 of them to get across the Earth. 3. So that gives you some idea of how big the Earth is. So that's good to have that idea. By the way, if we started here in Washington, D.C. and drilled a hole straight through the Earth, okay, so that's 3 United States is long, that hole, where would you come out? So the first answer was correct, somewhere in the Indian Ocean. You know what people often say, though, for an answer to that? They say China. And then you have to point out that, we're in the northern hemisphere and China's in the northern hemisphere, but if you went straight through the center of the Earth and came out the other side, you'd have to wind up in the southern hemisphere, wouldn't you? Anyway, we can then think about how big other things are, like the sun, maybe. And let's imagine this grapefruit is the sun. Okay, question is, how big is the Earth in comparison? Is it like the size of this apple? No. Like the size of this tomato? Size of the grape? Smaller. You know how small it is? Sounds like you do. The head of a pin. Now, I want you to just confirm. What's your name?
Caitlin.
Caitlin, can you confirm this is an actual pin, and there's the head of the pin?
Yes.
Now, that's going to be the size of the Earth compared to our grapefruit sun. Okay, so that's really tiny. 100 Earths side by side would be equivalent to the diameter of the sun. 1 million Earths could fit inside the sun. The sun is that big. Now, what is the sun? It's a star. But when I look at the stars in the sky at night, they look a lot different from the sun. Why does the sun look so much bigger and brighter? Because it's a lot closer, right? But it's still a star, and we can look at it in different ways. If you just look at it through a telescope with the proper filter so you don't burn your retinas in your eyes and go blind, this is what you see, maybe some sunspots. And with some specialized cameras and other instruments, we get other views of the sun. We see explosions on the sun, solar flares, and there's lots of activity going on in the sun there. If we zoom in and look at the surface, well, it's not a solid surface, but what looks like a surface, closely, we see something like this. You might have thought that McDonald's invented golden arches, but they were on the sun long before. Those are actually streams of gas, of ionized gas, that are following magnetic field lines. There are very strong magnetic fields on the sun. And in fact, it's these strong magnetic fields that are responsible for some of the explosions on the sun. And these explosions send particles and radiation toward the Earth, sometimes producing the northern lights, or southern lights if you're in the southern hemisphere, power outages, geomagnetic storms. Remember how big the Earth is compared to the sun? Here's another view of these loops of gas, but with an Earth on there. So, see, there's the Earth right there. So the sun is really huge. Now, we can compare the Earth to the sun. We can compare the Earth to the moon. If we look at the moon is about has 1/4 the diameter of the Earth. So if you put them side by side, this is what they'd look like. Now, another way to get an idea of the size of the moon is that, suppose I wanted to give you the moon as a gift. I want to gift wrap the moon. You know how big a piece of gift wrap I would need? Here's my Earth. I would need a piece of gift wrap the size of the continent of Africa. And with that, I could gift wrap the moon. Do you believe it? So the moon is about 1/4 the size of the Earth in diameter, so that might be about the size of this apple. So we have the Earth and the moon. And You know, I just happen to have a piece of wrapping paper here that is the size of Africa. Also happens to be the same shape. And so now I can just kind of wrap up the moon in gift wrap. Here you go. It's organically grown, by the way. Yeah. Okay, so now we want to get an idea of more of the distances in the solar system. So let's extend our model a little bit with some other planets involved. Okay, I'm going to have someone hold the sun for me. Sure, come on up. The advantage of sitting in the front. What's your name? Kaylee? Okay, why don't we have you hold the sun over here, because we're going to need some room. Okay, so I'm going to give you the sun to hold. Be careful, it's very hot. And I have the pinhead Earth here. And the question is, I don't need any more volunteers, but thank you anyway. Okay, now how far from the sun do I need to put the Earth if this is going to be to scale? Okay, so we're scaling down the whole solar system so that this, hold it up high so everybody can see. Okay, good. So that's the sun. This is the right size of the Earth, but what's the right distance now? Okay, so you think right here is pretty good? No. You think I should get closer? No? Oh, farther. Okay. So say stop when you think I'm at about the right distance. Okay, I hear a lot of stops so far, but I think I have to go a little farther, actually. Think this is good? All right. I'm glad we're doing this in this size room, actually. We just fit the distance from the sun to the Earth in here. And so on this scale, if that's the size of the sun, this would be the size of the Earth. Now, what I didn't tell you is that along the way, I passed right about here. You know what I passed? I passed by Mercury. And then right about here, I passed by Venus, okay, on the way to the Earth. Now, gee, if I want to go out to Mars, Jupiter, Saturn, I'm going to have to go a lot farther. And in fact, if I wanted to go out to Neptune, which is now considered the farthest planet, and feel free to ask me about Pluto later if you want, that'd be about 1/3 of a mile away. What about the next nearest star? The closest star to the sun, it's actually a small star called Proxima Centauri. It would be about the size of a cherry, located in California. The stars are really spread out. So I'm giving you an idea of just how vast space really is. Think about stars being spread out that much. We can also talk about the distance between Kaylee and me and how long it would take to travel from the Earth to the sun. Okay? Let's say we're going to fly. We have this airplane that can magically fly through space. 600 miles per hour. That's about how fast a 747 can go. Okay? How long does it take to get to California from here, by the way, in a plane? 5 hours, maybe? Something like that. Okay. How long to get to the sun? 17 years. Now, so if you don't mind sitting in an airplane seat for 17 years, you can go visit the sun. If you've got this magic airplane, of course, that can fly through space. Okay, now I have a question for someone who wants to do a math problem and who doesn't mind telling us your age. Okay, we'll take someone in the back this time. Yes, how old are you? I think I heard 14. Okay, 14. So here's the question. You're going to take a trip now to the sun. You're not going to stay there any length of time because it's just too hot near there. And then coming right back, okay? You're 14 years old. How old will you be when you get back? Very good. Many people will just add 17 to their age, and forget about the time it takes to come back. So you'll be 48. Oh, one last question. When you get back and you're 48 years old, will you be an old person? Interesting. I'll remember that. All right. Well, thank you very much, Kaylee. I'll take the sun back, and we will move farther out into the universe now. Okay. I mentioned this before. What is this? This is Mercury. This is the planet Mercury. And later on, we can talk about why Mercury looks so much like the moon. And then we have Venus. And there are, lots of clouds covering the surface. We can't see Venus, the surface of it anyway, just by looking in normal light. But there are instruments, radar in spacecraft, that can map the surface and actually find out what the topography is like. And we see something like this if we color code the continents there. The lower lying areas are blue in this image, and the continents which are higher are colored green. Okay, and then we can move out from Venus, and then we get to the Earth, which we talked about. And then beyond the Earth, we have Mars. Now, Mars has this huge canyon across it. It's actually a rift valley, if you want to be technical. But that is actually, even though Mars is a smaller planet than the Earth, that is actually a canyon about the same size as the distance across the United States. It's like 3,000 miles long. The Grand Canyon on the Earth would fit into one of the little tributaries in there. It's huge. It'd be an amazing place to visit. Mars also, by the way, has the largest volcano in the solar system, Olympus Mons. Okay. Mars was also, the first planet that a spacecraft visited, and we got close-up images of it. And I want to show you this image of the surface of Mars, because before I do, let me just remind you that when you look at the planets in the sky at night, when you look at Mars, it looks like a bright star, right? It just looks like a star. And back in the old days, 2,000 years ago, and more recently, people thought of the planets in the sky as gods. So and that's why the planets have the names that they do. Mars was the god of war, Venus was the goddess of beauty and love. And so there are some people who still think that the planets influence us in those ways. There's this thing called astrology, which is not a science, but lots of people think that Mars has some effect on how aggressive you are, Venus on what goes on in some interpersonal relationships maybe. Jupiter was, they have this idea that the planets are influencing our lives, and that's not true. After all, the planets are not gods, and the idea that they were is what astrology is based on. And what I love about this picture of the surface of Mars is that it looks like such an ordinary place. It looks like it could be a desert on the Earth. It's a place where you could go and walk around on. And maybe in your lifetime, for some of you, you'll see people going to Mars and walking around there. I actually don't think I will get to see that, because sending humans to Mars is tremendously challenging for many reasons. But we're going to hear more about that in the next talk, so I'm not going to say any more about that now. I think we are anyway. Would you like to see a sunset on Mars? Oh, there it is. Pretty interesting. And in case you want to see how big the planets that I've talked about so far are compared to the Earth, there you see from left to right Mercury, Venus, Earth, and Mars. Earth is just barely bigger than Venus. The others are smaller. But then when we get out to the outer planets, we've got Jupiter, which has 10 times the diameter of the Earth. And Jupiter also has this great red spot, right about there. And that's a giant storm about twice the size of the Earth. Can you imagine a storm like a hurricane twice the size of the Earth? It's constantly swirling around. And it's been there. This storm has been there for hundreds of years. We don't know how long it will last, but it's so huge, and it's driven by the heat down deep inside Jupiter. So it keeps going for a long time. Okay, then we have Saturn, and you can see how big it is compared to the Earth. And Uranus, pretty featureless, it's about the same size as Neptune, both larger than the Earth. And up until a year ago, we did not have any good pictures of Pluto. Were any of you at the last XSTEM conference? Yeah? So at the last one, I wouldn't have been able to show you these pictures of Pluto because we only got them last year when the New Horizons spacecraft got to Pluto. And this is what it looks like. Very interesting topography. Interesting geology, if you can use that word for something other than the Earth. Pluto is very small, though. Here is the size of Pluto and its moon Charon compared to the United States. So it's really tiny. And here is an artist's conception, a painting of what it would look like if you were at Pluto and Charon and looking back toward the sun. And if you're that far out, Pluto's so far away that the sun just looks like a bright star in the distance. That is really way out there. You know how long light takes to get to the Earth from the sun? 8 minutes. And to get to Pluto, how long will it take? Maybe 4.5 hours. Orion, the constellation Orion. It's maybe easier to recognize if you have lines connecting the stars. We don't when we look out in the real sky, but we can do that for you here. And this star up here, Orion's shoulder, that's Betelgeuse. And that star, and here's an image of Betelgeuse. Betelgeuse is so big that if you put Betelgeuse where the sun is, it would extend out to the orbit of Jupiter. That is a huge star. And if you look out in space, we see lots of stars, not just millions, but billions of stars. We are inside of a galaxy, the Milky Way galaxy. This is not the Milky Way galaxy. We cannot photograph the Milky Way galaxy from the outside like this. We'd have to go out thousands of light years to get to where we could photograph the Milky Way like this. But we see other galaxies just like the Milky Way, and this is one of them. So this is a galaxy just like the Milky Way, and if this were the Milky Way, we would be located about halfway out in one of these spiral arms that goes around. And that galaxy contains a few 100 billion stars. That's enough stars to give 50 of them to every person on Earth. Huge numbers of stars. And there are other galaxies. Galaxies come in groups or clusters. And sometimes, this is pretty interesting, galaxies collide. And so what happens is, here's a simulation, computer simulation of a galaxy collision. But we can see actual galaxies in space that are in the process of colliding now. They are colliding and they get all distorted. What's really interesting, two things are interesting about this. One is that the Milky Way, our galaxy that we're in, is going to have a collision with another galaxy in about 5 billion years. The Andromeda Galaxy and the Milky Way are heading toward each other. The two are going to collide. You don't have to lose any sleep over it. It's going to be a long time from now, but It's interesting to know that that happens. But the other interesting thing, remember how I said if the sun is here, the next nearest star is in California? There's lots of empty space between stars. So when galaxies collide, the stars don't hit each other. They pass right on by because there's so much empty space. But what's causing this distortion is a gravitational interaction. They interact gravitationally, and the gravity from one galaxy pulls on all the stars in the other galaxy. And so they end up having really strange shapes. So that's going to happen to the Milky Way. Stay tuned. And as we look out into space, we see billions of galaxies. In this image taken with the Hubble Space Telescope, every one of these little smudges of light is an entire galaxy with a few 100 billion stars. Okay, the last thing I want to show you is a planetary nebula that I discovered. Because, you know, at the beginning I said that this is about learning new things and the joy of learning. And there's also the joy of discovery sometimes. You know, sometimes you learn something new for the first time. You didn't know it before. But if you're really lucky, you discover something that nobody knew before. And I had that experience, and this is the Stingray Nebula. And you can Google it and see pictures of it on various web pages. There was a star in the middle. It blew off its outer layers of gas and formed this cloud around it. A cloud in space is called a nebula. And this is called a planetary nebula because when astronomers a long time ago looked at it through low-quality telescopes, they thought it looked kind of like a planet because it looked kind of round like a planet. So anyway, it's a planetary nebula. This is the Stingray Nebula. And what do you think it felt like to be the first person on Earth to see this? Way cool, as they used to say. Okay, I'll stop there and take any questions.